Good morning. In today's lecture, the first half you will discuss about some analysis in the clock sequential circuit analysis. Then later we will go to the registers, the second half. So analysis in the clock sequential circuits, we will not go through the design circuits yet. Now let's assume we already have an existing design. Now we need to make some analysis on it, which is to need to make like reverse engineering, to look at the design circuits and understand how is the working principle for this, or how we can convert these circuits into a mathematical model, or how we can convert this into a state diagram and state table as well. So we can, for example, this is very important in diagonizing some problems. So let's assume we already have a design that's built to do a certain topic. Then after that, we need to make an upgrade on it. So let's assume the engineer who was doing this left quit the job. Now you are in charge, or now it's your target is to develop these products. So the first part, you need to make sure that to understand how is the old product being done. So we need to look at the circuits, understand how it's work, find the mathematical or the algebraic model for it, then find the state space diagram, state space table. Then after understanding every specific task, you can make your modification. Or if you want to expand it, or if you want to diagonalize, there was an error in some topics. And that's it. So how we can do it? Analysis in clock circuits. So let's look at this design. Let's assume this design has already been done. Look at some observation by looking at this. We know this is AND gate, this is AND, this is OR. We have this one. What's this device? Is this flip-flop or latch? Flip-flop. And look at the flip-flop. Is it rising or falling? Rising edge. And what's the type? D flip-flop, right? Okay, so what I encourage you to make this analysis start from the inputs towards the outputs. So here, this is state A, here is state A bar. This is B bar. So let's look at this state. So here is input X. So here will be X, then follow with this point, this is X, here is X. However, and let's keep going, which is, this is X, here is X bar, so here is X bar. In sequential logic circuits, the feedback, in the combinational in the past, the feedback was not allowed. But here in sequential, feedback is allowed. We have a feedback, which is this called feedback. This is feedback. We've taken A as a feedback. But with feedback, you need to keep in mind that in the feedback, there must be an storage elements, which is this one. What's the point of it? In the feedback, this can be as, for example, A, or we can say A here, it can be or we can say A of T less than 1, here is A of T. Or in other words, we can say A of T here, A of T plus 1. So here, I think I messed it up, I'm sorry. Let me do it again. Here is the new value, here is the old value. A of T, here is A of T plus 1. Because this one will be stored in the next following cycle. This one is the old one. Okay? So there should be a storage element. This is storage element here. In order to have a feedback, there must be storage elements. Okay? Then, let me erase this so we can have a clear image. Sometimes we can use this as A of T, or sometimes we can denote it by A, this one A bar of T, or A bar. This one sometimes we can say A of T plus 1, or sometimes we can say A star. So the notation, if I use of T, then use A of T plus 1. If I'm using A alone without of t, then I'm using A star. A star means this is the new value, like the same way as A of t plus 1. Okay? It's just this notation that you need to be aware of. Whenever you see A bar, A star, or A of t plus 1, this means the same. Just different notation. Then the same way here, this is B star, here is B bar. Okay? Then let's look here. So there is a feedback of A. Follow this feedback. It goes here and here and where? And here. So by following this, let's write it. Here is A. Here is A. Keep in mind this is not A star. This is still A. Because the feedback comes from A, not from A star. Okay? Now, look at the other feedback from A bar. A bar, follow A bar, it goes here. So let's write A bar. Here is A bar. Do you agree with me? Now, look at B. Follow B. B will go here and here. So here is B and here is B. How about C or B bar? There is no feedback for B bar. Now make sure, is there any symbol for all of the gates? Yes, there is symbol AX, XB, A bar X, BA, and XX bar. Okay. So follow this inputs, it will be AX. Follow this, it will be BX. Then here, we will realize A star is actually equal to, we have OR, which is AX plus BX. Okay? Does this make sense? Look at the other one, other scenario. Here, we have A bar and there is X. There is AND, so A bar X, which is, this is the same as B star, which is, or B of t plus 1. Okay, clear? Then the last observation, the output, you will see in the outputs, most likely will not be connected to, it can be sometimes connected to states, sometimes it's not, but here is the output. So let's follow with the states. Here is OR gate, so A plus B. Then we have AND with X bar, therefore it will be X bar A plus B. So the output is function of states and inputs. Okay? Since the output is function of states and inputs, this is in Mealy model. Because Mealy model, output is function of states and inputs. However, in Moore model, the output is only function of states, not inputs. So by just look at the output, you can make this observation that this cannot be done in Moore model. This is only in Mealy model. Okay? You agree with me? Now, let's write the equation down. Our target is to look at the outputs and look at B star, A star. That's what we need to find. That's every time. When you make analysis in the sequential circuits, you need to make sure what's the next output of each state and what's the next update of each state, which is A star, B star, and what's the output, Y. That's our concern. So I'm going to write them down here. A of t plus 1, sometimes we denoted it by A star, which will be AX plus BX. B of t plus 1, or yes. Let me just talk a little bit about this. Here, D flip-flop, that's why it's called A star. I apologize for not explaining this. Okay, let me explain a little bit about this. I said this is A star. Most likely, the correct answer or the correct thing is not to mention it's A star. Let me do this correction. I apologize about this. I should say this is equal to D. Okay? And the same for that one. This should equal to D. So I can say this is D1, this is D2. Okay? Since this one is D flip-flop, therefore A star equal to D, right? This is the D flip-flop. So I'm going to rewrite it here. Equal to D. And D here is actually AX plus BX. Again, why? Because it's D flip-flop. Okay? Now it's correct more. Even like our first answer was correct, but here I'm trying to make it, how about if it's JK flip-flop? It will not be this is A star, it will be something else. That's why let's do it into this way, not as A star. Then let's talk about B. B, or in other words, sometimes we call it B star equal to D because it's D flip-flop. And look at D star, D2. Here's was D1, this one D2. D2 equal to A bar X. So we can write A bar X. Again, this is D flip-flop. Then the last one, which is Y, equals to what? Look at here, what we did talk about Y. X bar A plus B. X bar A plus B. Okay? Does this make sense? Now, we need to make the state table, and I prefer to use the generalized state table. So in this kind, it's better than using other because sometimes it can be confusing, but when we use the generalized state table, it will be much easier. Now, look at the states. How many states do we have? We have, look at the states and inputs. How many inputs do we have? Look at this circuit. 1, right? Which is inputs X. Do you agree? Now, how many states do we have? Which is how many flip-flops do we have? 2. So we have states A and B, right? So, when we have states, sometimes we can make them as a shortcut. So we can donate A by, let's keep it as A and B, okay. Then let's make the truth or the state table so here is state A, here is state B. Those related to the present states. Okay? Then we have the inputs, which is X. Then we have next states, which is A star, B star. Then we have the output Y. Okay? Do you agree with me? This is the generalized state table. Now, how many outputs do we expect to see? I said we have 2 states, I mentioned, and 1 inputs. So the total of 3. So we have 2 power 3, there will be 8 combinations. So we can make a truth table like this. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. The regular truth table. Just look at its in this side. Present states and inputs, group them together. Then we have next states and outputs. There will be another scenario. Now, how can we find A bar, B bar? Why? It's similar to any truth table that we know earlier, or any problem like that we know earlier. Just look at the equations. We already know A, we already know X, B, X, then you can find A star. Then the same way, we already know a bar x, and we already know x bar a plus b. That's how we figure it out. Okay? So you can do the equations. Then, for example, for a star, is ax plus bx. If everything is 0, then it will be 0. B star equal to a bar x. Since x is 0, then it will be 0. Then y equals to a plus b. X bar, since both a and b are zeros, this will be 0. And so on. So let's go to another scenario. If x is 1, but a and b zeros, this will make it 0. Then if x is 1 and a bar, this will make it 1. Then this will make the output is zeros. Then for 0, 1, let's substitute b is 1. We have x is 0, therefore a star will be 0. For b star, a is 0, a bar is 1, but x is 0, this will make it 0. Then for y, we have a is 0, b is 1. 0 plus 1 will be 1. X bar, 0 bar will be 1. This will make it 1. And so on. Just let's go here with 0, 1. So we have x is 1, therefore this will make it 1. Here, since b is 0, x is 1. This will make it 1. Y will be 0 because a is 1, b is 1. I'm sorry, 0. A is 0, b is 1, while x bar, 1 bar will be 0. This will make it 0. So, and so on. I mean, I'm going to give you the final answer for 1, 0. This will be 0, 0, 1. Here, this will be 1, 0, 0. This will be 0, 0, 1, and the last one will be 1, 0, 0. Okay? Now I just did the state table. Again, why it is 8 combinations? Because we have 2 power 3. We have two states, 1 inputs, or 2 flip-flops, I can say. Let me change it by 2 flip-flops. 1 input, so the total 3, 2 power 3, 8 combinations. Then use the equations to do that. I think everyone knows how to do it. Is there anybody that don't know how to do this? Okay. Now, after doing all of this, we are ready to do the states diagram. The state diagram, again, to do it, we need make sure that we cannot apply Mealy model. We need to apply only Moore model. I'm sorry, we cannot apply Moore model. We need to apply Mealy model because output is a function of inputs and states. Therefore, we will use Mealy model. We cannot use Moore model. Okay? Now, how we can draw this? Look at the combination in the states. We have 0, 0, then 0, 1, 1, 0, 1, 1. So we have 4 combinations, right? Do you agree with me on this? Look at the state table. So, let me draw it here. We have 0, 0, 1, 0, 1, 1, 0, 1, 1. Okay? Then, again, since I'm doing Mealy model, the inputs and the output will be on the arrows. Look at first scenario. 0, 0, we are at 0, 0. If the input is 0, we will remain at 0, 0, the output is 0. 0 over 0. Do you agree? If the input is 1, we will go to 0, 1, which is this state, if the input is 1, and the output will be 0. So you see, using the generalized model, it will make it much easier to follow. Then 0, 1, if the input is 0, we will back to 0, 0, and the output is 1. And if the input is 1, we will go to 1, 1, and the output is 0. We will go to 1, 1, if the output is 1, and the output is 0. And let me write it here. Okay? Then let's go here. 1, 0, if the input is 0, it will go to 0, 0. 1, 0, if the input is 0, it will go to 0, 0. Sometimes, to avoid this shortcut, to avoid this intersection, we will make like this. Or even, if you intersect, there is no bullets, then it will be fine. Okay? Now, 1, 0, if the input is 1, I think, let me go back a little bit too. If the input is 1, 0, the output is 1. I forget to put the output is 1. Then if the second part, if the input is 1, it will go to 1, 0, which is remain, and the output is 0. Now 1, 1, look at 1, 1. If the input is 0, it will go to 0, 0, and the output is 1. Here 1, 1, if the input is 1, it will go to 1, 0, and while the output is 0. Okay? Does this make sense? So that's like we did a reverse engineering. Converts the circuits that we have. First, identify all of the circuits. There is AND, OR, as we did here. AND, OR, NAND, exclusive OR, etc. Then look at the storage elements, D flip-flop, JK flip-flop, T flip-flop, SR flip-flop, etc. ZD latch, and so on. Then identify all of the inputs and the outputs of each gates until reaching like D or J or K, as we see here, D1 and D2, the outputs. Find the equations of the outputs, find the equations of the flip-flops, these algebraic expressions, then make the truth table based on the flip-flops, storage, and based on the outputs, or in the inputs, to find the next state and the output, as I showed you here. Then you can make the state table easy, state diagram, based on this. Any question? Okay. Here, state table is the same way that I draw here, the same way. And let's forget the other parts. Just forget about this. This is state table the same way that I draw here. But you see my sequence, I make 0, 0, 0, 1, 1, 0, 1, 1. And this diagram is the same as my answer, but you see 0, 0, 0, 1, 1, 0, 1, 1. Just changing the orders. It doesn't matter. Whatever you want to do, you can do. I prefer to make it as clockwise, 0, 0, 0, 1, 1, 0, 1, 1. But if you want to use any other approach, again, you have the choice. Even like if you don't want to make them as a square, if you want to make them, for example, like in one line and do this, it can be fine. You're free to do whatever design you feel more comfortable. So this is the same as our design, and this is, I don't know why I'm repeating this, so this is just repeated circuits. Okay, let's look at analysis with SR latch. As we know, the excitation table for SR latch, most likely when there is S and R, we will be in hold mode if they are both in zeros. If 0 and 1, we will be in resets because R is 1 in resets. If S is 1, we will be in sets. 1 and 1 is not allowed, right? This is as we know in SR latch. Do you agree with me? Now, how can we make the state table for this? Can we make a state table and logic diagram? Yes, we can. How? This is, we can associate with the states as state R and look at Q. Q related to the states. So, to the S and R are inputs. This is present states. This is next states. So we realize that this is actually built on or based on the excitation table, based on the generalized model. This is part of the generalized model. The generalized model, we have inputs. Here the inputs are S and R. We have present states, which is Q. We have next states, which is a Q star. Then outputs. But here, there is no outputs. Then, therefore, this is actually the same as the generalized model. The excitation table that we used to see in the past, this is the same as the generalized model. Okay, how can we make the state diagram? We have two inputs, one present state, so 2 power 3, which is 8 combinations, right? So we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay? Now we can split it into some period, like during the first one, when S and R both are zeros, we will be in hold. Hold means no change in the status. So Q will be 0, Q star, and Q star, the other part will be 1. The second parts, when S is 0, R is 1, in both cases we will be in resets, which means Q star will be 0 and 0. The third quartz, which is we have 0, 0, 0, 1, 0, which is set, it will be 1, then it will be 1 and 1, because we'll be in set mode. Then the last one, it's not allowed, therefore it's forbidden states. I'm going to write them as X, forbidden states. Okay? So, how can we draw this? Sometimes in the generalized model, we write it as, here is present states. If you want to rewrite it, present states. Which is Q. Then here, the inputs, S, R. Then we have here next states, which is Q star. No outputs, so don't worry about the outputs. So I'm gonna just flip these Q and SR, the location of Q and SR, flip them, so it can be easy to implement the state diagram. So here it will be like 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So let's look at this again in terms of Q. So S and R, 0, 0, which means hold, then will be 0. R equal 1, this means reset, so Q will be, start will be 0. S equal 1 set, the Q will be 1, 1, 1, this means forbidden states. 1, 0, 0, 1, and we have 0, 0, this means we are in hold, this will be 1, 1, 0, 1, this means we are in reset, this will be 0, 1, 1 0. We are in set. This will be 1 1 1 1, which is in hold. Okay? I just redo this. What's the point of doing this? Because most likely, let's go back in the last example, when we did this charts 0 0 0 1 1 1 1 0, you'll see the states were in the first part of the truth table, then the inputs in the next parts. That's what I did here. I make the states, present states here, then the inputs next. I make just the states at the beginning. Then I'm ready to do the flowchart, the states. So you will see here there is no outputs. So I don't need, there's no slash over something like 0 over 0 or, so we cannot say that it will be applied on Mealy model or Moore's model. There is nothing like that because there is no outputs. Then there is only state table without any outputs. Look at the states. We have one option of zeros, the other option of ones, right? So we can do two circles. One circle at 0, the other circle at 1. Because we have only 0 or 1. This is the only we have. We have only Q. It's not like in the first example we have A and B. Here we got only Q. Q, a Q star. There is no Q1, Q2, Q3. There's only one Q. Then there is only 0 and 1. However, for the inputs, we have two inputs. 0, 0, 0, 1, 1, 0, 1, 1, and so on. So let's follow the first part. So look at 0, and with 0, 0, Q star will be 0. Therefore, the next state will be 0 if we have 0, 0. Two inputs, then I wrote 0, 0 close to each other, because this is two inputs. Then, with 0, 1, it will be 0. So, I can put a comma, 0, 1, it will be in the same arrow. Okay? Third part, which is, with 1, 0, I will go to 1. So it will go to 1 with 1, 0. 1, 1, it's forbidden. Therefore, don't draw it. Forbidden. Don't draw it. Okay? Then just remove it. Neglect this. Here at state 1, with 1, if the input 0, 0, it will remain at 1. 0, 0, remain at 1. If the input is 0, 1, it will go to 0. It will go to 0, which is 0, 1. If the input is 1, 0, it will hold, which is remain at 1, which is here 1, 0. If it's 1, 1, forbidden, don't draw it. Then that's the state table and state diagram of SR latch. Okay? Then we can do this for any other circuit. We can do the state table for D flip-flop or D latch. We can do the for gated D latch, gated SR latch, and so on. So you can do that, whatever. So this is one example for doing this. Let's look at another analysis, like analysis with D flip-flop. Let's assume we have this flip-flop, and we need to make some analysis, like make the state table, state model for it. So here, locates, this is X, here is Y, this is X exclusive OR with Y. Then what will happen here, there is feedback, this is A, it will go here A, then it will be X exclusive OR with Y, exclusive OR with A. This is equal to D, and since we are with D flip-flop, D flip-flop, so A star will equal to D, and D here is actually X exclusive OR with Y, exclusive OR with A. Okay? Do you agree with me on this? Now, do we need to make the exclusive OR to find the equations? Yes, you can, but sometimes it can take so long. Here we need to make the truth table or the state table. Remember, in exclusive OR, it is odd function. means that count number of ones. You can go back to lecture number 2, I think. Lecture number 2, it's already been mentioned. I'm just going to write a revise. Count number of ones. If they are odd, then the output will be 1. If they are even, the output will be 0. However, exclusive NOR, this is even function. This means if they are odd, it will be 0 when you count them, number of ones. If they are even, this will be 1. Okay, so how can we use this in building the state table? Look, we already agreed that we said D, A exclusive OR with X and Y, therefore A is T, which is the same as A star, like this. Look at how many inputs do we have? 2 inputs, right? How many flip-flops we have? 1 flip-flop. Therefore, the total is 3, 2 power 3, we have 8 possibilities. Okay? Let's draw state table. To draw the state table, we have a present state, which is the present state is A, or the state table here. Then we have inputs, and we have 2 inputs, which is X and Y. Then we have next state, which is A star. Then outputs, we don't have here an output, therefore leave it empty, like this. Since we don't have outputs, we cannot say use Mealy or Moore's model, because again, there is no outputs. Mealy or Moore's model, they are just different in the location of the output. Since there is no outputs, just draw the state diagram. That can be applicable for everything. So this state diagram, as we did like here, for example, there is no outputs, then this is neither Mealy or Moore's model. It's just like state table, whatever. So here again, there is no outputs, therefore I remove it. We have states, present states, and inputs. Look at the present states and the inputs, then do the truth table, because we have 8 possibilities, as I showed you here. 2 power 3, 8 possibilities. So we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, then 1, 1, 1. Okay? Now, the nice feature of the exclusive OR, A exclusive OR with X, exclusive OR with Y. And I said that exclusive OR is odd. So let's count the number of ones. If they are odd, then the outputs or the next state is 1. If they are even, the next state is 0. That's the nice feature that you need to figure out. So here is the easy part. The difficult part, which is converting exclusive OR into their equations, which is A, X bar plus, or X, Y bar plus X bar Y. Then you need to apply this with the A. This will take so long time, take a lot of efforts, then the chance of getting mistakes will be high. So sometimes when you see these kind of questions in the exam or in the quizzes, when you see sometimes using the nice feature of as shortcuts, so you can solve this question within 5 minutes, or you can spend 20 minutes and you will get a lot of mistakes. So we don't need to convert this to their equations. We can use the nice feature. 0, 0, 0, 0, we don't have 1, so the next state will be 0. 0, 0, 0, 1, which is odd number, we have only 1, 1, so it will be on. Then 0, 1, 0, which is odd, then it will be 1. 0, 1, 1, we have 2 1s, therefore it's even, then it's 0. Here it's odd, will be 1, even will be 0. Here is odd, here is even, will be 0, here is odd, will be 1. Okay? Do you agree? Now I'm ready to do the state table. To do the state diagram. I'm already done the state table. Let's do the state diagram. Look at the present states. We have a group of zeros, a group of ones. Therefore, we have only 2 circles. 1 circle for zeros, the other circle for 1. Okay? So let's do with 0. Let's look here. When 0, 0, it will remain at 0. Here, remain at 0 when 0, 0. 0, 1, go to 1. 0, 1. Then here we have 1, 0 will go to 1, therefore I'm going to put comma 1, 0. Here is 1, 1 will go to 0, so 1, 1 is here. Let's look at 1. When 0, 0, it will go to remain at 1. When it is 0, 1, go to 0. When it is 1, 0, go to 0. So here is comma 1, 0. When is 1, 1, remain at 1. This is the state diagram. Okay, clear? Any question? Okay, so you need to make sure to be familiar how to make some analysis like this, because definitely you will see this in the final, which is you will have a circuit and understand this circuit. Like look at the circuits, find the model for it, or find the equations, the state table, make the state table a state diagram. Let's look at another question, but let's have JK flip-flop instead of like D flip-flop, because on all of the previous examples were D flip-flop. How can we do our analysis? Again, look, start from the input. Here is X. So here will be X bar. Let's follow with X. This is X. Here is X bar. Then what else? This is X bar. Then locate the feedbacks. So here is A. A will follow with A. It will go here. So here I'm gonna write here is A. Then look at the feedback of B. Here is B. It will go here. Okay? Now, keep going. Let's see how will it be. Oh, there's another feedback of B, I forget, which is will go here. This is B as well. Now, we need to look to see what are the values of J, K for each one. Is there any outputs? Here we don't have outputs, so that's it. This is JK flip-flop, because we see a clock and JK, and the other part, they are all rising edge. So look at J1, K1, J2, K2. J1, basically, it's equals to B1, B, right? K1 equals, since there is and, B and X bar, which will be BX bar, right? Now we are done with the first flip-flop. Let's go to the other one. J2, it's equal to X bar. Okay? K2 equals to A exclusive OR with X. Keep it like this. You don't need to simplify it. Okay? Is this clear? Now, let's write down the values. I'm going to write them here, because here I think they are the answers. So let me write them here to go step by step. Now you agree with me that J1 equal to B, K1 equal to BX bar, right? And you agree with me that J2 equal to X bar, K2 equal to A exclusive OR with X, right? Now, let's talk about the flip-flop with A. The flip-flop, JK flip-flop A star equal to J1 A bar plus J1 bar A. Do you agree with me on this, the equation flip-flop? You know that equation flip-flop, JK flip-flop, right? Which is, it used to be as Q star equal to JQ bar plus K bar Q. I think I forget to write K, I'm sorry. J Q bar plus K bar Q. Clear? Understood? Then here, A star will be J1 A bar plus K1 bar A. Substitute J and K. So which will be J1 is equal to B, so it will be A1 bar B. I prefer to use the alphabet, that's why I flip A and B. Or let me write it, then let me write it correspondingly then. I will do the alphabet, the shortcut later. So it will be B A1 bar plus K, which is B X bar times A, right? Then do the simplification, or let's make it easier, which is it will be A bar B plus A B X bar. I think I forget something, which is the bar here, right? Forget this. Please, you need to be careful. There's a bar because it's K1 bar. And according to De Morgan's, how to do the bar, B X bar all bar, this equals to B bar plus X, right? So I'm gonna rewrite it here, which is gonna be B bar plus X times A. Okay? Do you agree? Okay. So, as a result, it will be A bar B plus A B bar plus AX. Okay? So this is the equation of A star, or sometimes we can call it A of t plus 1. Come on. This is the equation of A star. On the other hand, let's look at the equation of B star. B star equal to J2 times B bar plus K2 bar times B. Okay? Is this clear? Now let's substitute them. J2, as we see here, is X bar. So it will be X bar, B bar, plus K2 bar. K2 is actually A exclusive OR with X, and there is a bar above them, times D. Here I have no choice. I need to make sure to substitute the equation of the exclusive OR, which is, I think, that you already memorize, or you already have this in your note card in case if you happen to forget this. So which is going to be here, B bar X bar, I made it like the alphabet order. So here it's going to be A X bar plus A bar X, all bars, times B. Then let's apply like De Morgan's on it, which is going to be B bar X bar plus this multiplication will be addition, which will going to be A bar plus X. Then this addition will be multiplication, which is going to be A plus X bar, and reverse them, then times B. So let's do the analysis more an analysis. B bar X bar plus A bar times A bar A, plus A bar X bar, plus X times A, plus X times X bar, they are all times B. Then we know X times X bar 0, X times X bar 0, A times A bar 0. So as a result, the answer will be B bar X bar plus A bar B X bar plus A B X. This is B star. So this is the second equation. So you see, dealing with JK flip-flop sometimes can make the analysis more difficult. However, in D flip-flop, it's much easier. Just the function will be as D, or A star will be D, or B star will be D. But here, A star equal to J A bar plus K bar A. You see, so dealing with JK flip-flop sometimes will make it harder, but it's not impossible. Now, how many inputs we have? We have one input. One input. How many outputs? No outputs. How many states or flip-flops? 2 flip-flops. Therefore, 2 power 3 equal 8 possibilities. Right? Let's make the state table on it. So here, present states, then which is related to A and B. Then we have inputs, which is X. Then we have next state, which is A star, B star. Then we output, we don't have output, so there's no outputs. Okay? Even though you don't need to mention all the outputs. So, okay, I need to redraw it. I'm sorry. Okay, 2 inputs, 1 input, 2 inputs, 2 flip-flops. Therefore, 2 power 3 equals to 8. Then, let me rewrite it here. Present states, we have A and B. Then, inputs, which is X. After that, we have outputs. Next states. We don't have outputs here. So here 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. What's the next states? We have A star, B star. Output, there is no output in don't worry about making this. So in order to find this, you can substitute in the equations. Find A star, we have A equal A star B plus A B bar plus AX. So here B bar X bar, A bar B X bar, A B X. So this will take some time to substitute this. And you need to be careful when you substitute them to get the outputs. So I'm going to write the final results. I'm not going to spend, it might take 10 minutes or maybe to calculate this. So I'm going to give you the output here. The final result, this will be 0, 0, 1, then 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1, 1. Okay. Now look at the states. We have several combinations. We have 0, 0, then 0, 1, 1, 0, 1, 1. Therefore, there can be 4 circles. There is no outputs. Don't worry about Mealy or Moore's model. There is no outputs. If there is any outputs, look at the output. Is this a function of states or not? If it's a function of states, then, or if a function of inputs or not. If it's a function of inputs, we cannot use Moore model. Use only Mealy. If it is a function, if it's not a function of inputs, if it's only a function of states, then you can use both Mealy or Moore's model. The overall general, like the model that can be valid for any time, which is Mealy model, it can be valid, whatever, if it is depending on the state or not. Then let's make this like present states. We have, several options. We have 0, 0, 0, 1, 1, 0, 1, 1. Then let's locate at 0, 0. 0, 0 with input 0, it will go to 0, 1. With input 1, it will remain at 0, 0. Now 0, 1 with input 0, it will go to 1, 1. With inputs 1, it will go to 1, 0. Now let's look at 1, 0. With input 0, it will go to 1, 1. With inputs 1, it will remain at 1, 0. Now 1, 1 with input 0, it will go to 0, 0. With input 1, it will remain at 1, 1. Then that's it. Okay? So you'll see here, we've done several examples. All of them are look at the circuits, find the equations, algebraic equations. This is the first part. The second part is to do the state table. Then the third part is to do the state diagram. That's what we expect to see in these kind of problems. And you will see them, again, as I mentioned, in the exams or maybe the quizzes as well. So these are very important to make these kind of analysis. So here is, okay, the JK flip-flop equation. So let's go to another equation, which is the last example before the registers, which is called related to T flip-flop. Look at this circuits. We need to do the same scenario, the same scenario that we did earlier. Then I think there is a typo mistake. Here is the output Y. Okay, so now we have outputs. At the same time, we have states. How can we deal with this problem? Again, start from the inputs. Look out for any feedbacks and see. Here is X. This is X. I'm going to write it here. This is X. Then this is X, right? Look at the feedback, or actually here is A. This is A. And this is B. Here is B, right? Is there any feedback? Yes, we have a feedback from B. Come on, this is A, this is B. Look at B, the feedback from B, it will go here, right? So, this is B. Then, since there is AND, it will be BX. Here, it's X. So now, we have T1, T2. T1 equal BX, T2 equal to X. Do you agree? Y equal to AB. So, we can say that T1 equal to BX, T2 equals to X. As we know in the T flip-flop, Q of T plus 1 or Q star equal to TQ bar plus T bar Q, right? Which is in the same way, just T exclusive OR with Q. So let's substitute for the first one to find A star, which is going to be T A bar plus T bar A. Substitute T with BX, which is going to be here T equal to BX, T1 of course, BX times A bar plus BX all bars times A. Apply De Morgan's, it will be BX A bar plus B bar plus X bar times A. Be careful. BX all bars does not equal to B bar X bar. It will equal to B bar plus X bar. Okay? Remember this. Then it will be, let's make the algebraic on alphabets. A bar BX plus A B bar plus AX. This is A star. Look at B star. B star, which is T2 B bar plus T bar T2 bar times B. Then T is equal to X, T2 equal to X, so it will be X B bar plus x bar b, or in other words, we can say exclusive OR, which is x exclusive OR with b, and that's it, which is exclusive OR much easier. Yes?
In the A star, I think it's supposed to be plus AX at the end, or AX bar.
Yes, AX bar, actually, there was a typo mistake. Okay, thank you. Yes, AX bar, right. So as a result, this is the equation of A star, this is the equation of B star. We have the output, don't forget the outputs. So the output, here it is, there is AND gate, so AB. Therefore, we can say the output, the third equation, y equals to AB. So this is the third equation. Then, look at the outputs. Is the output function of states and input or function of states? What do you think? The states are A and B, while the input is X. Is Y function of X? No. Therefore, Y, or the output, is not function of it's not function of inputs. Therefore, in this example, we can apply Moore model if it is required. Why? Because the output is only function of states, not function of, it's not a function of inputs. But you have the choice, or actually depends on the question. If it says that use Moore model or use Mealy model, or sometimes if there is no information, then just use Mealy model. Like that, let's make it our default. So let's make the truth or the table, the generalized model. That's why I like the generalized model. It can be valid no matter if I'm using Mealy model or Moore model. Just let's use it. And it's very practical because we are making the truth table as 0, 0, 0, 0, 0, 1. Then just follow the equation. So it will be much easier to do analysis other than what we see in the textbook. I think I did prefer the method that's been used in the textbook. I prefer this one. So let's make the state table. We have a present state. What we have here? Present states. So let's look how many flip-flops. We have 2 flip-flops, 1 input. Therefore, 2 power 3 equal to 8 possibilities. So present states, we have A and B. Then we have inputs, which is X. Then we have next states, which are A star, B star. Then we have outputs, which is Y. I prefer to isolate to make double lines here. So when we do the truth table, it can be easier for us to follow. So it will be here 0, 0, 0. I'm going to make a line. 0, 0, 1. Make a line. 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 1, so 1, 0, 1. Then 1, 1, 0, 1, 1, 1. Okay? Then look at the equations. So the outputs, be careful, it's function of A and B. Not A star, B star. Okay? A and B, I'm gonna write it. Not A star, B star. So, to find the outputs, A and B, just AND gates. 0 times 0, 0. 0 times 0, 0. 0 times 1, 0. 0 times 1, 0. 1 times 0, 0. 1 times 0, 0. 1 times 1, 1. 1 times 1, 1. Okay, so the output can be found very easy. Look at B, is exclusive OR with X. Just count the number of ones with B star, and B star exclusive OR with X and B. So here is X and here is B. 0, 0, 0. 0, 1, this is odd 1. 1, 0, odd 1. 1, 1, even 0. 0, 0, 0. 0, 1, odd 1. 1, 0, odd 1. 1, 1, even 0. So we just found B and Y in a very easy way. Now the last one is how to find A star. This will take some time by substituting this in the function here. And forget this is A bar, BX plus AB bar plus AX bar. So it will take some time. I'm going to write the final answer, which is going to be here 0, 0, 0. Then we have 4 ones, 1, 2, 3, 4. Then we have zeros here. So that's the outputs. Okay? That's because I mean A star. Any question about state table? So the next step is to do the state diagram. Look at how many possibilities do we have. We have 0, 0, 0, 1, 1, 0, 1, 1, 4 possibilities. So we can say that I can write it as a general formula. Number of possibilities, or number of circles equals 2 power number of flip-flops. So we have 2 power 2 equal 4 circles. Okay? So let me draw the circles here. 0, 0. Then 0, 1, 1, 0, 1, 1. Then let's look at them. So with 0, 0, input 0, the next states will be 0, 0. The output will be 1, will be 0, right? So it will remain at 0 when the input is 0, and the output is 0. That's why I put slash over 0. Okay? This is Mealy model. If the input is 1, it will go to 0, 1. And the output is 0. If the input is, here let's go to 0, 1. If the input is 0, it will go to 0, remain at 0, 1, and the output is 0. If the input is 0, 1, it will go to 1, 0, and the output is 0. Then at 1, 0, if the input is 0, it will remain at 1, 0, and the output is 0. If 1, 0, if the input is 1, it will go to 1, 1, and the output is 0. If it is 1, the output is 0. Then with 1, 1, if the input is 0, it will go to 1, 1, remain at 1, 1, and the output is 1. If the input is 1, it will go to 0, 0, and the input is 1. Output is 1. Okay? Do you agree? This is written in Mealy model. Now this one can be done in Moore model, because the input is not function of outputs. The output is not function of input. So we can write it as this way. 0, 0, the output is 0. 0, 1, the output is 0. 1, 0, the output is 0. 1, 1, the output is 1. So we can do it in Moore's model like this. It will be 0, 0 over 0, this circle. Here is 0, 1 over 0. 1, 0 over 0. 1, 1 over 1. That's the difference. Then you can say if the input is 0, it will remain 0. If the input is 1, it will go here. If the input is 0, it will remain here. If it is 1, it will go here. If the input is 0, it will remain here. If the input is 1, it will go here. If the input is 0, it remains here. If the input is 1, it will go here. And this is written in Moore model. So this is, like in today's lecture, this is the only example that can be done in Moore model. Any question? So it seems we don't have enough time to go to registers, so let's stop here. And this will be our next topic, next lecture. Thank you so much.